Imagine you are a brilliant and handsome scientist with a real functional time machine at your disposal. You get in the machine, adjust the destination to 100 years in the past, and pull the lever. As you look outside the machine, instead of the expected roaring 20s, you see only the void and the distant stars as you float in outer space. The logic behind this scenario, often repeated by random people on the internet, is that while you moved through time, only through time, the machine didn't account for motion through space. It sounds like a gotcha argument, right? But does it hold up? Or is it just selective physics? The argument points out that Earth is not at a static point in space. It is performing a frantic cosmic dance, changing location at every moment. The planet spins at roughly 1,000 miles per hour around its axis. It orbits the Sun at 67,000 miles per hour. And the Sun itself drags us around the Milky Way at a staggering 500,000 miles per hour. If your machine travels back 100 years but remains stationary in the exact same spot, Earth simply hasn't arrived there yet. You would find yourself in an empty vacuum, millions of miles away from home. Therefore, time travel is impossible because you'd be left stranded. Hello, I am catLulu. Welcome to the channel. Today, we will dismantle the floating in space fallacy. To claim that a time machine stays still while Earth moves away, you first have to define what still means. And strictly speaking, there is no way to tell where something is without comparing it to something else. This isn't just physics, it is basic logic. Think about it. If you text a friend, "I am waiting 50 meters away," they will think you have lost your mind. 50 meters away from what? The pizza place? Your house? A hungry tiger? Without a specific landmark to measure against, the number 50 is useless. It is the same for the universe. You cannot simply say, "I am at coordinate XYZ. You have to ask, XYZ relative to what? To define a location, you need a coordinate system attached to a specific object or observer. We call this anchor, a frame of reference. Now, here is the problem with the argument. For the floating in space scenario to happen, the time machine cannot be using Earth as its frame. Otherwise, it would simply move with it. The argument implies the existence of a fixed universal frame of reference, a master grid that sits stationary behind everything, independent of Earth's motion, to which the time machine attaches. Historically, humans actually believed this existed. There were two main candidates for this universal frame of reference. Candidate number 1, absolute space. This was proposed by Isaac Newton. He viewed space as a rigid, immovable container, a mathematical three-dimensional wireframe that could define absolute position in X, Y, and Z coordinates. If this existed, it would serve as the ultimate frame of reference. The time machine could lock onto the grid, and Earth would simply fly away from those coordinates. However, Einstein demonstrated that space isn't a rigid grid. Mass, like Earth, curves space. If space can bend, twist, and drag, it cannot be absolute or fixed. Result: the wireframe itself is mutable. Candidate number 2, the luminiferous ether. In the 19th century, physicists believed light was a wave, like sound. Sound needs air to travel, so they assumed light needed a medium too. They called it the ether, a physical, stationary substance filling the universe. If this ether existed, it would act as a physical frame of reference. But as Earth moves, we should have felt an ether wind blowing against us. This wind is what the Michelson-Morley experiment tried to measure in 1887. But they found nothing. Zero wind. Einstein drove the final nail in the coffin when he realized that light is a self-propagating electromagnetic field, and therefore does not need a medium like the ether. Here is the catch. The floating in space argument requires something like absolute space or ether to be true, or the time machine could only attach to a frame that is not absolutely stationary. So it assumes the machine anchors itself to a universal grid, which we know does not exist. An extraordinary claim like this requires proof. If there is no such grid, the statement the machine stays in the same place is scientifically meaningless. Same place, relative to what? Everything in the universe is moving in relation to something else. Nothing is really completely still. There will always be movement depending on the frame of reference. But catLulu, there is a universal frame, the cosmic microwave background. Checkmate. Fine, let's talk about it. The CMB is the oldest light in the universe, the afterglow of the Big Bang. It is a cloud of photons zipping through the cosmos. And yes, although it is moving, technically, we can use it as a background to measure our speed. Here's how it works. Think of the CMB as rain. The raindrops, photons, are moving at a regular, known speed. If you stand still, the rain falls evenly on your roof. If you drive fast, the rain smashes harder against your windshield. Likewise, due to the Doppler effect, the wavelength observed from the CMB shifts toward blue. In the rear window, the rain hits more gently, similar to a redshift in the CMB's wavelength. You can calculate exactly how fast you are driving by measuring the difference in how hard the rain hits the front versus the back of the car. So, when scientists say the CMB is a reference frame, they don't mean it's a fixed floor. They mean it is a universal background flow that we can measure our speed against. Besides, Earth, the starting point of the time machine, is not stationary relative to the CMB. Therefore, for the floating in space argument to be true, your time machine would have to ignore Earth, ignore the Sun, ignore the galaxy, and arbitrarily lock its GPS coordinates to the Big Bang itself. Why would a machine built on Earth do that? That isn't a law of physics. That is just a terrible engineering choice. Now, you ask, if there is no universal grid, and we aren't locking onto the Big Bang, what prevents the machine from flying away? What does it attach to? Well, sorry, hairball. I meant, it doesn't need to attach to anything. It just needs to respect the law of inertia. Let's look at a simpler example. Let's apply the logic of the floating in space argument to an elevator. Imagine you are a good-looking guy who steps into an elevator. For those not familiar with the apparatus, an elevator is a machine that transports you through the spatial Y dimension, up. You get in the machine and press the button for the 20th floor. When you look outside, instead of the expected destination, you see only the void and the distant stars as you float in outer space. Remember, Earth is performing a frantic cosmic dance at hundreds of thousands of miles per hour. If the floating in space logic were true, the moment the elevator lifted off the floor, you should fly away at supersonic speeds because you stopped moving with Earth along the X and Z dimensions. Obviously, that doesn't happen. Why? Conservation of momentum. Think of momentum simply as stored movement. If you are on a train moving at 100 miles per hour and you jump, you don't smash into the back wall, because even though your feet left the floor, your body is still traveling forward at 100 miles per hour. You and the train share an inertial frame. In simple terms, you are locked inside the same bubble of motion. A time machine is no different. It sits on Earth. It has mass. It is a heavy physical object. Because it has mass and is spinning around the sun at 67,000 miles per hour, it holds a massive amount of momentum, nature's memory of motion. Basically, the machine wants to keep flying forward. So, unless the time machine has a magical brake that slams against the fabric of space, that imaginary universal grid we just debunked, stripping away all its stored speed, you will naturally travel with Earth, even as you travel through time. You don't float away because you are inertially glued to the planet. Finally, we must address the mechanism of the machine itself. We aren't talking about H.G. Wells anymore. In modern physics, time travel requires manipulating general relativity. You don't jump coordinates, you bend the path. Most robust theoretical model for this is the Alcubierre metric, or a warp bubble. In this scenario, the ship doesn't move through space. It contracts space in front of it and expands space behind it, creating a bubble of flat spacetime that carries the ship and its local reference frame along with it. Think of it like a surfer on a wave. The surfer doesn't need to paddle to match the speed of the ocean. The wave carries him. If you warp to travel back to 1925, you are effectively surfing a space-time wave through history. You don't lose your spatial anchor to Earth, because inside your bubble, you are bringing your local inertial frame along for the ride. Thus, the argument that time travel leaves you floating in space is based on a misunderstanding of how the universe works. It correctly applies orbital mechanics to Earth, but applies fantasy physics to the machine, ignoring inertia, relativity, and common sense. Therefore, there's no need to worry about the void. Worry about the paradoxes. Thank you for joining me on this journey through time and space. If you enjoy seeing such misconceptions dismantled and deep dives into sci-fi, physics, and philosophical curiosity, subscribe to the channel. Like, share, and stay tuned for our next episode. Until then, and farewell, curious humans.
We chase the anchor, the